progeria. The individuals here are the 18 children diagnosed with progeria. And for each of them, we measure the pulse wave velocity in meter per second. So that's our variable, and it's a quantitative variable. The objective here of the study is that knowing that in the population of healthy children, pulse wave velocity values that are above 6.6 are considered abnormally high. And what we would like to know is whether in the population of children with progeria, on average, the pulse wave velocity is abnormally high. And so that would mean on average greater than 6.6. So the first thing we're going to do is identify the parameter of interest here. And the parameter of interest is going to be the mean pulse wave velocity in the population of children diagnosed with progeria. You'll notice that we're not going to say the mean mu is 0 because that would make no sense. It's not biologically even reasonable or feasible. We're talking about a threshold value that is meaningful. So in particular, what we would like to know is, on average, do we have evidence that pulse wave velocity exceeds 6.6? So the alternative hypothesis is going to be that mu is greater than 6.6 meter per second in this population. Now, the opposite of that would be that mu is equal to or less than 6.6. However, we're going to need one very specific null hypothesis so that we can then do the computations for the p-value that assume the null hypothesis is true. And so we're going to choose the threshold value. So the worst case scenario that is still not abnormally high. So mu equals 6.6. So your working hypothesis is that mu is 6.6 or less, so not abnormally high. But the null hypothesis you're going to use to obtain the p-value is specifically mu equals 6.6. All right, so we're also going to have to check whether the conditions for inference are met. So here we have a representative sample of humans, so that's good enough as a random sample in this case. And we need, therefore, in addition, that the data are roughly normally distributed because we have a sample size of just 18. So very, very mild skew possibly, but not more than that. So we have the raw data. Here I just got a dot plot, and you can see that we have some roughly even distribution here over the whole range. There's no obvious skew, no clear outliers. So the data are appropriate for a t-test. We can import this as a data set from PSLS4E. So notice that it means that in the URL, you must have the correct textbook. So this is the data for the textbook PSLS4E. You can make, for example, a dot plot for those values. So we're going to do the T, one sample. We have the raw data. So in here, we need mu equals 6.6. And then we do have a one-sided in the greater than direction for our alternative hypothesis. So we calculate, we get a test statistic of 6.816, which is the question you were asked. Again, if you want more precision for your p-value, you would need to go to preferences, and then doing the same test, you get this p-value 0.0000015. So 1.5 e negative 6. You were asked to also obtain the confidence interval. So we can do the same thing, one sample. And instead of testing the hypothesis, we just ask for a confidence interval. And we get the interval 10.6 to 14.3. So this is the 95% confidence interval for this parameter, the mean mu, the mean pulse wave velocity in the population of children with progeria. So the p-value tells us we have very strong evidence that in the population of children with progeria, the mean pulse wave velocity is abnormally high, or that the pulse wave velocity is abnormally high on average. The confidence interval tells us that with high confidence, with 95% confidence, we believe that the mean pulse wave velocity in this population is a value between 10.6 and 14.3 meter per second. And notice that 10 to 14 is clearly higher than 6.6. So this is much more informative. Clearly, the p-value tells us about the strength of the evidence, that there is something going on, that it is abnormally high on average, whereas the confidence interval allows us to say that, yes, it is abnormally high and clearly so in a substantial manner.